All right, so today we're diving into something pretty wild, actually. It's this idea of, like, should we engineer the climate? And you sent over this Scientific American article. And it really digs into this whole concept of geoengineering.
Right.
And, you know, we talk about climate change a lot, obviously a huge, complex issue. But this is like taking it to a whole other level. Like, what if we could just, you know, adjust the thermostat for the entire planet?
Yes, it's a big one.
That's kind of what geoengineering is getting at.
Yeah.
So the article lays out a few different ways people are thinking about this. And I got to say, some of these are really out there. So the first one is solar radiation management, or SRM. And basically it's like saying, what if we just try to dim the sun?
Yeah, that's one way to put it.
And how would they even go about doing that?
Well, the idea is to release sulfur dioxide into the stratosphere. Okay. And that would create this kind of reflective layer, so it'd bounce some of the sunlight back into space.
They're like putting up a giant sunshade for the Earth.
Yeah, essentially.
Wow. And is that even something that, like, is that even possible?
Well, it's interesting you mentioned that because the article actually brings up a natural example of this.
Okay.
The Mount Pinatubo eruption back in 1991.
Oh, right. I've heard of that.
That eruption, it released a massive amount of sulfur dioxide. Like, we're talking 20 million metric tons.
Wow.
And it actually did have a noticeable cooling effect on the planet for a couple of years.
So it's like nature kind of gave us a little preview of what this SRM thing could do.
Exactly.
Okay, so we've got dimming the sun. What else? So the article also talks about this other idea, ocean fertilization. And this one's all about using the ocean. It's like a giant carbon sink, which it already is. But this is like taking it to another level.
So the idea here is you basically sprinkle iron into certain parts of the ocean, and iron acts as this fertilizer for phytoplankton.
Phytoplankton?
Yeah, they're these tiny little algae, but they are incredibly efficient at absorbing CO2.
So it's like we're giving the ocean a boost.
Yeah.
And its natural carbon cleaning process.
Exactly.
Interesting. So we've got dimming the sun, supercharging the ocean. What else is there? Okay, so the last one that the article mentions is direct air capture, or DAC. And this one sounds like something straight out of a sci-fi movie to me.
It does, doesn't it?
Giant machines sucking carbon out of the air.
Yeah, basically they act like giant vacuum cleaners for the atmosphere.
Wow, so instead of trying to like mess with the sun or the ocean, this is more about cleaning up the mess we've already made.
Yeah, and that's actually led to some debate about whether DDoC even counts as geoengineering.
Oh, really? How so?
Well, some experts argue that because it's not directly manipulating natural systems in the same way as, say, SRM or ocean fertilization, it shouldn't be lumped in with those.
So it's all about how we define geoengineering then.
Exactly.
But I imagine even with DDoC, there are still concerns, potential downsides.
Oh, absolutely. We're still talking about really complex systems here.
Yeah.
And we don't fully understand the potential consequences of messing with them on a large scale.
Right. Always easier said than done.
Exactly.
So we've got these tools, right? These like almost hard to imagine ways of actually influencing the entire planet's climate. But the big question is like, should we even be considering this?
Right.
And the article gets into this whole debate. And it's interesting to see how, even within the scientific community, perspectives are kind of shifting on this.
Yeah, definitely. I mean, the article even mentions how just a few years ago, geoengineering was like almost taboo, you know, among scientists.
Really?
Yeah. But now, more and more of them are saying, hey, we need to be looking into this. We need to be researching this seriously, maybe even doing some small-scale trials.
So what's changed?
Well, I think a big part of it is just how urgent the climate situation is becoming.
Right.
Like their article mentions that latest IPCC report, and the message there is pretty stark. You know, we are very unlikely to meet our climate goals without some pretty drastic measures.
So it's almost like if we're headed for a brick wall, we can't rule out, you know, grabbing the wheel and trying to swerve, even if it means potentially making things worse.
Yeah, it's that kind of level of thinking.
But of course, there are big concerns, right? It's not like everyone's just on board with this. The article even talks about protests against geoengineering experiments.
Yeah.
Especially from indigenous communities.
Yeah, there's a lot of fear and distrust around this.
So what are some of the biggest concerns that people have raised?
Well, one of the biggest ones is this idea of a slippery slope.
Okay.
The concern is that by even researching geoengineering, we make it more likely that it will actually be used, even if we don't fully understand it, or if there isn't a global agreement.
It's like we're opening Pandora's box.
Exactly.
And then on top of that, there are the ethical questions, right?
Oh, absolutely.
Like who gets to decide?
Right. Who gets to decide if we tamper? with the entire planet's climate system.
And what if something goes wrong?
And with something this complex, something will almost certainly go wrong.
Then what? Who's responsible?
Exactly. And those are really tough questions.
Yeah, and it's not like the consequences would just be contained.
Right.
Like we're talking about potentially impacting the entire world.
Yeah, and in ways that are really hard to predict. Like we could end up disrupting rainfall patterns, affecting agriculture.
Wow.
Even inadvertently causing harm in some parts of the world while trying to help others.
It's just, there's so many factors.
Those are just the ones we can foresee.
Right. Who knows what else we might be unleashing?
Exactly.
It's like we're stuck between a rock and a hard place. On the one hand, we've got this urgent threat of climate change. But on the other hand, trying to engineer our way out of it seems incredibly risky. So where do we even go from here?
That's the million-dollar question.
Yeah.
Right.
And I don't think there's an easy answer.
Yeah.
It really comes down to, how do we weigh these huge potential risks against the potential benefits?
And I guess the other question is like, even if we did manage to slash emissions, which is a big if in itself, would it be irresponsible to not at least explore geoengineering further, like maybe as a backup plan?
Yeah, I think a lot of scientists would say, even if we just view it as an insurance policy, we need to understand how these tools work, what the potential consequences are, because we might be in a situation someday where we have to make a really tough call.
And then there's that whole other issue of how do we even control this? Like if we do start researching geoengineering, who gets to decide what's off limits?
Right. It's not like any one country can just start messing with the entire planet's climate.
This has to be a global effort with a ton of transparency and cooperation.
Which, let's be real, is not exactly humanity's strong suit.
Well, that's the thing, right?
Yeah.
The article even suggests that the mere threat of geoengineering might be enough to finally get countries to take climate action seriously.
So it's like a bargaining chip.
In a way, yeah. Because if countries start to think that other countries are seriously considering something as drastic as geoengineering, it might scare them into finally taking those more traditional steps, like reducing emissions, investing in renewable energy.
Wow, so it's like this weird reverse psychology thing.
Kinda, yeah, but it just goes to show how high the stakes are getting.
Definitely a lot to think about there. Big thanks to Scientific American for this article. Really made us grapple with some tough questions. And to everyone listening, we want to hear from you. Did this deep dive change how you think about tackling climate change? Head over to our website, leave a comment. Let's keep this conversation going. Until next time, this has been your deep dive.